Hello everyone, and welcome back to BK'sTechStack. Today, we're kicking off a crucial programming refresher, focusing on Python functions. By the end of this session, you'll be able to confidently create and utilize functions, understand their advantages for code organization and reusability, and explore advanced topics like variable scope, generators, and functional programming methods. Let's get started.
Functions are fundamental to writing efficient and clean code. At its core, a function is simply a self-contained block of statements designed to perform a specific task. They only spring into action when you call them, and you can pass data to them as parameters. The benefits are immense. Functions boost modularity, reusability, and ultimately, the quality and scalability of your entire codebase.
Let's look at the mechanics. Defining a function in Python starts with the def keyword, followed by its name and any parameters it takes. The function's logic resides in an indented block. Calling a function is straightforward. Just use its name with the required arguments. Python supports both positional arguments, where order matters, and keyword arguments, offering more flexibility. Plus, you can set default values for arguments, making your functions even more versatile.
Python offers incredible flexibility with function arguments. The *args syntax allows you to pass a variable number of positional arguments, which are then collected into a tuple. Similarly, *kwargs handles a variable number of keyword arguments, collecting them into a dictionary. Once a function has processed its data, the return statement sends results back to the caller. Remember, if no explicit return is present, Python functions default to returning none.
A critical concept in programming is variable scope, which defines where a variable can be seen and used. In Python, variables defined inside a function have local scope, meaning they're confined to that function. Variables defined outside any function or class, however, have global scope, accessible throughout your code. Python follows the LEGB rule for variable lookup. If you need to modify a global variable from within a function, remember to use the global keyword.
Moving on to generators, a powerful feature for memory-efficient iteration. A generator is essentially a function that produces a sequence of values one at a time, using the yield statement. Unlike return, yield doesn't terminate the function. It pauses execution, returns a value, and then resumes from where it left off on the next call, preserving its state. This makes them ideal for processing large datasets without consuming excessive memory. You can use them with next or in a for loop.
Finally, let's explore Lambda functions and Python's functional programming tools. Lambda functions are concise, anonymous functions, perfect for quick, single-expression operations. Their simple lambda arguments expression syntax makes them very handy. These pair perfectly with functional methods like map, which applies a function to every item in an iterable, filter, which selects items based on a condition, and reduce from the functools module for cumulative operations on an iterable.
And that concludes our programming refresher on Python functions. We've covered a lot, from the basics of function definition and arguments to advanced concepts like arbitrary arguments, variable scope, and the efficiency of generators and lambda functions. Mastering these concepts is key to writing robust and elegant Python code. Keep practicing, and I'll see you in the next session of BK'sTechStack.